If you line up all the planets in our solar system, you'll notice a pattern. Earth, Mars, and Jupiter all spin on their axes like tops. But the seventh planet is different. Uranus spins at a nearly horizontal 98-degree tilt. Because of this severe tilt, it doesn't spin through space like a normal world. It lays on its side, rolling along its orbital track like a bowling ball. This creates the most extreme weather cycle in the solar neighborhood. Uranus takes 84 Earth years to orbit the Sun, meaning one pole is locked in direct sunlight for 42 years straight. Then the planet slowly rolls forward, plunging that same pole into 42 uninterrupted years of pitch-black winter. In the vacuum of space, massive celestial bodies do not simply fall over. The physics of angular momentum dictate that a planet will remain upright as it spins, indefinitely, unless an outside force intervenes. This featureless, pale blue sphere appears perfectly still, yet every detail of its current orbit points back to the solar system's most violent cosmic hit-and-run. Billions of years ago, a wandering protoplanet made of heavy rock and ice, roughly twice the size of Earth, slammed into Uranus. Computer simulations show this was not a head-on collision. A direct strike of that magnitude would have shattered Uranus entirely. Instead, the incoming world delivered a massive grazing blow, scraping along the edge of the atmosphere just hard enough to permanently knock the planet off its axis. The strike ejected a massive cloud of planetary shrapnel. Over millions of years, that debris coalesced into 27 moons and 13 cold dark rings. Because the planet was now on its side, this debris field formed vertically, matching that new 98-degree angle. The sheer violence of that era is permanently recorded on the moon Miranda. Scientists refer to it as the Frankenstein moon because its surface looks like someone smashed a sphere with a hammer and hastily glued the puzzle pieces back together in the wrong order. That fragmented crust features Verona Rupus, an ice cliff so deep and burdened by gravity so low that if you stepped off the edge, you would fall in free fall for 12 straight minutes before hitting the bottom. The entire system, the vertical rings, the shattered moons, the sideways spin, functions as a frozen splash pattern from that ancient disaster. Neptune is furthest from the Sun, so it should be the coldest planet, but Uranus is actually colder, plunging to negative 224 degrees Celsius. Scientists trace this to the collision. The impact buried its hot core beneath dense rubble, trapping the internal heat forever. If you could dive into that freezing outer atmosphere, the first thing you'd notice is the stench. Spectroscopic analysis confirms those upper clouds are saturated with hydrogen sulfide. The entire planet smells heavily of rotting eggs. Below those toxic clouds lies a vast, highly pressurized mantle made of liquid water, corrosive liquid ammonia, and thick methane slush. The crushing pressure at this depth literally shatters the methane molecules. The free carbon atoms bond together, harden, and fall toward the core as a continuous rain of solid diamonds. All of that swirling, electrically charged slush generates a chaotic magnetic field. Instead of flowing neatly from the geographic poles like on Earth, the magnetic center of Uranus is tilted 60 degrees and offset from the core. As the planet rolls forward, this warped magnetic field corkscrews wildly through space, flickering open and closed every 17 hours. The protoplanet impact physically broke the planet from the inside out, choking off its heat source and tangling its magnetic engine. For decades, astronomy textbooks treated Uranus as a featureless world. That conclusion came from a single flyby by NASA's Voyager 2 probe in 1986. The probe arrived during a massive solar storm, which compressed the atmosphere and smoothed out the cloud layer. We caught the planet at the worst possible moment. It was sitting completely silent in the middle of a decades-long seasonal hibernation. In 2007, the long winter ended. The planet reached equinox, allowing sunlight to hit the equator head-on for the first time in half a century. And this time around, we finally had the Hubble Space Telescope watching. The sleeping giant woke up. Massive, violently churning continent-sized white storm clouds erupted across the bright cyan atmosphere. Telescopes clocked surface winds tearing across the planet at 900 kilometers per hour, nearly triple the speed of Earth's strongest hurricanes. Oddly, these violent winds were moving in retrograde, blowing entirely in the opposite direction of the planet's rotation. Uranus proves that even the most distant outposts in our solar system possess highly active, volatile atmospheres, just waiting for a shift in the seasons. Relying on a brief, 40-year-old flyby is no longer acceptable. That is exactly why NASA has made the Uranus Orbiter and Probe mission their absolute highest planetary priority for the upcoming decade. The blueprint is ambitious. NASA plans to lock a spacecraft into a long-term orbit to map the chaotic magnetic field, while dropping a secondary robotic probe straight down into the crushing, toxic clouds. It will survive just long enough to sample the hydrogen sulfide and transmit live data from the diamond-raining depths before the sheer pressure implodes it. To understand the extreme boundaries of planetary physics, we have to go back and investigate the frozen scars of the planet that got knocked over.